Assalamu alaikum everyone. Today we are going to conduct lecture number 12 of this online course, and today's topic is assembly language programming. Yes, in this lecture we are going to enter in the assembly language programming part, which is very important and actual goal of this course. So let's proceed to the introduction of assembly language programming. Okay, before we enter into assembly language programming and see how a programmer performs different instructions and set of commands in assembly language programming, we need to be familiar with certain terms, and so very first term we are going to discuss is software. We know that microprocessor doesn't know how to process data because itself microcomputer doesn't have any information what is data, from where it should be taken, or in other words, microprocessor or microcomputer must be told about these things, what exactly it need to do. I mean, we know that microprocessor is a machine which performs according to instructions. So it needs to be instructed, it need to be told what to do. Okay, from where it gets data, what to do with the data which he gets from different positions. Maybe he's getting data from a register, maybe he's getting data from storage outside the microprocessor, so he need to know. And of course, and most important thing, if he has processed the result and if he has processed the data, where need to be that result to be sent. Okay, so where to put that specific process result. So these are important jobs, and these are done by one thing which is called software. So all of these things are basically software jobs. So we must know what is a software. So software performs following job. It tells microprocessor what to do, it tells where to get data, it tells what to do with the data. For example, maybe it tells you need to apply addition operation, maybe it tells you need to apply subtraction operation, and so other logical operation. And furthermore, very important thing, once data is processed, so where to put that result, that is also the job of software. So software is a terminology which combinedly performs these different jobs. Next thing we need to understand is program. And program is nothing but sequences of commands or set of different commands, and each of the command tell microprocessor what he is supposed to do. So each command itself is known as instruction. We can also call it basically statement. Uh, Furthermore, program may be uh, composition of just a single line, but it can be a composition of 1,000 lines. So program can be very simply just a one line program. For example, add 2 plus 3. It is a simple straightforward things, but program may be written for performing a very complex task which involves number of steps of number of operations to be performed as a individual steps of that complicated task. So program may be composition of 1,000 lines. So what is a program? It is set of different instructions, and it tells microprocessor what to do. And program may be so simple of just composition of few line or a single line, or it may be composition of 1,000 lines. Microcomputer fetches each and every instruction one by one. That is very important fact, and we have already gone through different concepts while we were following through code segment and stack segment. So microprocessor fetches each and every instruction one by one and similarly executes instruction one by one. One thing we learned about 8086 or 8088 microprocessor was parallel processing, and in parallel processing, by the usage of parallel processing, microprocessor 8086 or 8088 enabled that while they are fetching next information, they can work on execution of current statement. So the logic still implies to or the principle is still applies to the 8086 or 8088 microprocessor. So microprocessor fetch each and every instruction one by one and similarly executes them one by one. So overall task of computer is accomplished. So that means, for example, program is written of 1,000 lines and microprocessor going to fetch one line, then execute it, then microprocessor going to fetch another line and execute it. So once 1,000 lines are executed, then the overall computer task will be accomplished. Okay, again we are going to discuss about software, and software is variety of programs. Basically one can say software is culmination of or composition of many programs which involves variety of programs, but they can be categorized into two major types. And what are those? First is known as system software. What is system software? A group of programs which combinedly enable microprocessor to run smoothly. That means there are some programs or some group of programs which are basically responsible for management of overall microprocessor for microprocessors processes. So they actually enabling microprocessor to run smoothly. Without these management programs or management softwares, a microprocessor cannot run smoothly. Very very easy example of system software is operating software, for example Windows and those and so on. Second type is basically application software. Application software are those collections of programs which are basically useful for specific functions or for user defined functions. Like one wants to paint inside microcomputer, like one wants to do some documenting using Microsoft Word, like one want to present using Microsoft PowerPoint. So these are basically what application softwares. So there are two important types of softwares. One is system software, which is mainly responsible for management of overall microprocessor, like operating system, and the other one is application software. And application softwares are basically for the user defined special functions, for example documentation, like I explained. Okay, in this slide we are going to discuss about machine language, and machine language is native language of microcomputer or microprocessor. Or in other words, one can say machine language is the only language which can be understood by microcomputer or microprocessor. Machine language is nothing but simple combinations of ones and zeros, so it's kind of coded form. That is why it is normally referred as machine code. So machine code and machine language both are same thing. Furthermore, single instruction, we know that each and every program is combination of various instructions or various commands. So single instruction can take one or multiple byte. If you remember, while we were discussing about bus interface unit, we discussed one thing which we named what instruction queue. And instruction queue's length was 6 byte in case of 8086 microprocessor. And we learned that basically there can be more than one byte and more than one byte in a single instruction, so they need to be queued in a queue while one byte of information is under progress, so next byte of instruction is ready to be processed. So that was a thing that we learned in bus interface unit. That point actually explains the same thing. Single instruction can be composition of one byte or multiple byte. For example, if there are 24 bits which are forming just single instruction, that means that single instruction will be composition of how many bytes? 3 bytes, because these are 24 bits. Similarly, a single instruction can be composition of 32 bits. That means how many bytes? 4 bytes. So instruction can take more than one or multiple bytes. Okay, that is very interesting point. We know that machine language is nothing but combination of ones and zeros. So humanly it's quite impossible to write machine language instructions for microprocessor. We need someone who performs intermediary role between human being and what? And to microprocessor. For example, we know that there are some high level languages, for example C or C++. In C or C++ or other high languages, what is so important? Why they are called high level? Because they can easily be understood by human being. because they normally use keywords like if, else, while, do, for. What are these? These are so simple English words which can be easily understood by human being, while those high level languages cannot be understood by uh, machine or microcomputer who understand only machine language. So there must be some intermediary stage between high level language and machine language, and that is assembly language, which is the original goal of our course. What we are going to learn in assembly language is basically an intermediary stage between high level language and a machine language, so that one can actually program close to microprocessor, more close to microprocessor, because those are not really high level words, but they are very close to human being, but as well as close to machine language. So let's see what we are going to learn in assembly language. Okay, what is assembly language? Assembly language is again combination of different alphanumerical symbols. That means we can use ABC, we can use 1, 2, 3, 4, 5, 6, and so on. So numbers and alphabets both are combined to make symbols for assembly language. We're gonna see, or we're gonna explore those symbols in a short while. Before that, let's explore it in more detail. Single assembly language statement represents single instruction. That is simple principle which is valid for every language. A single statement is actually equivalent to single instruction, which tells and what a statement specifies for any microprocessor. It tells microprocessor what operation is to be performed. For example, addition, subtraction, negation, or any other operation, and what data are to be processed. That is very important terms, that these two functions which actually leads towards two different part of instruction. So every instruction can be divided into two different parts. What are those parts? First part is opcode, and opcode identifies the operation to be performed. For example, you need to transfer certain information. So transfer is what? Operation. You need to add certain operands. So add is what? Operation. You need to subtract, you need to multiply, you need to divide. So all those are basically what? Operation. So opcode is a part of instruction which tells the microprocessor what operation is supposed to be performed. And for example, add, subtract, divide, and etc. So I already explained it to you. Each opcode is assigned to a unique letter combination called mnemonic. That is very important term that we are going to explore in a bit while. Just hold this term for few slides and you will learn, okay, that is called mnemonic. But remember, mnemonic is kind of another name for opcode, and this is kind of unique letter combination. What is this unique letter combination? We're gonna explore it. So second part of instruction is operand, and operand, what it describes? It describes data to be processed. It tells, okay, this is the data that you need to process. Remember, opcode was explaining what? Operation. Here operand is explaining the data to be processed. It also explains whether source or destination of data is register or of storage outside the microprocessor. So it also explains where is the data coming from. Okay, that is very important part of instruction. Remember, opcode is just telling you, okay, that is just an addition instruction, or that is just a memory transfer instruction. But operand part is the one which is actually telling you what is the source of data, what is the destination of data. So these two letters or these two parts combinedly make any instruction. So that is why these are so important and integral components of instruction, and we're gonna see them by example as well. Okay, in this slide we are going to explore very first instruction. It's quite easy. So it says add ax comma bx. Add ax comma bx. This add is basically opcode which tells us that what? You need to perform addition. So basically operation is coming to be realized by microprocessor about this part of instruction which is called opcode. The next part of instruction is operand, which is telling us, okay, these are what? AX and VX. These are simply data registers. So we are coming to know that addition is supposed to be performed between AX and BX. So add, remember I told you to hold on for a while. What is a mnemonic? Mnemonic is a special uniquely letter combination. For example, in this case it is A double D add. If you're gonna write A double D, that will be realized in 8086 add opcode. So it is opcode which tells microprocessor 8086 or 8088 that you need to perform addition operation. Then next thing we understand source operand. Okay, that thing is interesting. Let me write one more thing. Okay, destination operand. Okay, that thing is basically just beside the opcode is your destination, right? And after destination we write source. So here source code is, source operand is what, BX, and addition and AX is basically our destination. What does it actually tells you? It tells that you need to add, okay, we are going to add what, AX plus BX. They're supposed to be added, and the result should also go to AX. So AX is written in as a destination operand. So result, whatever the result of AX plus BX, it will go to where, AX. So that is why that destination operand is AX. Here we see another example. It is bit complicated, or we see multiple parts of instruction. First part is start. It is just a label, and let me raise it so that it become much more clear. You see there is a colon. Look, there is a colon in this label, which is the part of the label. Then we see opcode. Opcode is simply M over move. Move means transfer. Okay. Then we see operands. Okay. BX is gonna source, and AX is supposed to be destination. So whatever the value of BX is going to be copied into AX, and this part, this latter part, is basically simple comments. And whenever in this assembly language you are going to write comments, you need to put a semicolon before comments. So everything you're gonna put after semicolon is will be counted as a comments. So this instruction is basically showing us several parts of instruction. Start, which is a label. We are going to explore that label thing in data transfer or control instructions. For a while we can just ignore them. Opcode is telling us what operation is supposed to perform, and in this specific example it is move. AX and BX are basically operands, data operands, and BX is serving as a source operand. AX is serving as a basically destination operand, and latter part is just a comment part. So label is of course start, mnemonic is move, source operand is BX, destination operand is AX. And one thing which is important to understand here or to note down here is label and comments are optional part. Remember, in the last slide we saw instruction without these two parts. So these are kind of optional part, and one can actually avoid these parts. So normally we don't use them unless they are required. Okay, it is another instruction which is increment SI. Remember, SI is one of the index registers which is source index. So increment is basically opcode here, which is telling microprocessor that you need to increment. Increment means addition of 1. Okay, then SI is operand part, which tells us, okay, that is the thing that you need to increment. So this is your data, and this is our comments, right? Because these are written after what, after semicolon. So everything coming after semicolon is going to be your comment. So it clearly explained that SI plus 1 will go into the SI. That is the operation of this whole instruction, that 1 will be added to SI and result will again store into the SI. So mnemonic in this specific example is increment, INC. INC stands for increment. Source operand is SI, and again destination is also SI. So it is kind of unique instruction. So we may see some instruction in data set of 8086 or 8088 microprocessor where there will be only one operand, like in this example increment Si. I hope I have explained the concept. Okay, we are almost done with our this lecture, but we need to remind ourselves with certain points. So assembly language cannot be run directly by a processor. What does it mean? Remember, assembly language is something which is not written in ones and zeros, and microprocessor doesn't understand anything else but ones and zeros. So assembly language cannot be processed directly by a microprocessor. What do we need? We need a translation from assembly language to machine code. So this translation is a must step, and who will perform this translation for us? And that is called assembler. So there are two terms what we are going to learn. One thing is called source code. Source code is nothing but a simple assembly language program that we are going to write in assembly language. So that will be input to the assembler. And object code, assembler, in the response to this input, he will generate an output which will be in form of what? Machine code. So output of assembler will be machine code, and that is normally known as object code. So this is the complete procedure. We gonna write something in assembly language program that is called source code. We will provide it to the assembler. Assembler will perform certain translation here, and it will provide an object code. And object code is nothing but a machine code program which can be processed by microprocessor. So that is the complete procedure which is required before we gonna process it by a microprocessor. So these are steps. I hope I have explained them clearly. Okay, that's it from this lecture. uh, we have tried to go through basics of assembly language programming. We have seen different kind of instructions, their different parts, how those object and source code come into the picture while one is going to deal with assembly language programming. So if you have got any question regarding these basic terms, please note them down, and we are going to deal with those queries in online session. Thank you for listening.